then again, I have these interactive embeds here. Why don't I just... I guess I have to take these out too. Okay, and then it worked. So if I use the skip animation preview equals true, and I don't have the interactive embeds. Maybe these interactive embeds should just not work if skip animation preview is true. And I think that'd be a lot more natural, actually. I think it would. So let me go into scene. And then interactive embed. And now, no, hold on. Oh, god damn it. Dope, okay. Interactive embed. Now this can just check that flag. If self dot skip animation preview, just return, just don't do anything. So now I don't have to change my code here, hopefully. If I run this, perfect. I can still interact here, and I can quit it, or I could rerun it, I guess. Nice. Nice. So now I can start the next step of this. I think I'm gonna want to pause or like label these. Supposed to be vertices for this interactive embed, or I'll put it there. It's the project shader. This is the primitives generation. Great. Okay, so now I'm going to want to pretty much cover this with squares. Just to start out, I'm going to handle the labels. I need another label here. Let me get some text. So go to the same place, the primitives generation label. Okay. Then I'll fade in the rasterization label. Okay, so I'm gonna see that work. Oh man, it didn't keep going. Oh wait, no, that makes sense. Then I queue. Okay, so that did make sense. Just put an interactive embed at the end of that. And this was good, so I'm gonna move this down. Okay, now rasterization. How am I gonna animate this? I think I can just take a point. I just want to I think I can just take a point. I just want to overlay this with like squares, I guess. No, not that. I'm gonna want to have an array of squares that covers the triangle. And I'm gonna have them all appear iteratively and cover the triangle. I think that's what I want to do. It's gonna be a very similar picture to this. Okay, so let me try just overlaying a grid of dots on this triangle. So I'm gonna say grid. I basically need a starting point, and then the width and the height. Let me say grid start. Actually, let me just place a dot. Let me just place a dot here. So I'm gonna say start. OpenGL dot. This will be triangle. Get top. And I don't remember what get top returns, so I'm gonna check that. Get edge center. Okay. Triangle that get top. At 1. So that's the y coordinate. Okay. So this is going to be the up portion of that. As for the right portion of that, it's going to be get right. Or get left. Yeah, this time's right. Okay, then I'm going to add this dot. And I think I broke something. Oh, nope. And that did not work. Okay. Oh, this should be a 0. And then we skip this too. Nice, I think that's perfect. Yeah, that's fine. So then the loop that I want to do is going to be for I equal I and range. Then I want the length of this grid, the width of this grid. Let me just do width. And for J and range, then I want the height of this grid. And I'm going to want to, I'll just pass. I'm going to place a square, right? Now, what's that width going to be, and what's that height going to be? Let me get, I'm gonna call this top left. I'm gonna get the bottom right. I'm gonna get the right here, and get the bottom here. I'm gonna place a dot at both of these. And I think I broke something. Width is not defined, that's true. This whole thing should be commented right now. Okay, that's perfect. Yeah, that's perfect. Oh, you know what'll actually be annoying? figuring out if a point is contained within this triangle. How can I do that? Hmm. Hmm. I guess I can think of one way. If I like take a normal vector that's pointing toward the inside and I ensure that the dot product of the point with that normal is positive, maybe that'll do it. I think so. Maybe. I might have to just look that up. But anyway. So now I know the width and the height. So I'm going to say width, or like grid width, is going to be the bottom right. And I gotta need that x coordinate minus the top left. I get the x coordinate of that. That's the width. I grid height. I'm gonna get the top left. Get the y coordinate. Check the bottom right. Get that y coordinate. Okay, I'm just gonna print these. Three and three. Okay. Sounds good. I think that actually makes sense from the way I chose the points as well. So then I'm going to... I think I'm going to make a square be 0.1 or so in width. So now I can say Brian range grid width for Jan range grid height. And I actually want this. I want this divided by however large the width of a square is. Let me do square side length. And this is going to be, I'll put it at 0.1. The same with this. I'm going to place a square and place it where? For now, I'm actually going to make this a dot. I'll just self.add an OpenGL dot. I'll move it to, and where will that be? Well, it's going to be the top left. Actually, I'll solve for the location over here. Top left plus right times I times the square side length. It might actually be off by half square side length or something like that. But I'm going to start with that. So I'll do this. I'll say dot location plus equals right times the squared side length. Then dot location plus equals down times j times the square side length. Okay, and I'm gonna move this to the dot location, add that dot. And if I'm lucky, maybe this will cover this triangle with dots. Or it'll crash. NumPy float 64 can be interpreted as an integer. Okay, I think that makes sense. It seems to be this sort of division. Okay. Same thing. I wonder what this number is. Same thing. I wonder what this number is. I'm probably just going to cast it to int. 29.0. Okay. So yeah, I'm just going to cast that to int. Oh my gosh. Square side length. Dot locate. Oh, this should be dot get center. Top left is a object. It's a dot. Okay. Well, that didn't work. And why didn't it? Top left dot get center. Top left dot get center. Right times I times the square side length. Down times j times the square side length. I wonder why it would come out that way. I'm just being bad at Python. Guess the first thing to do is print I and j and square side length. This looks right. Yeah, this looks right. Okay. First things first, I'm just going to place them all on the top left. Okay. Especially if I don't add the top left and top right dots. Okay, then I can see that. Now, I am gonna move them to the right. Okay. It does seem like it's going too far, though. And why would that be the case? Right times I times the square side length. And it's just ignoring j. I is corresponding to the width. Dot move to dot location, that's right. Yeah, I have no idea why these would increase gradually. Maybe if I just print out the eyes that are being used? Okay, why would it ever go this far? I wonder how far that goes. Yeah, that goes for quite a while. Okay, so that's going way further than it's supposed to. Is dot location? Oh, am I updating the top left git center each time? Do I want to do this dot copy? I think that's closer. I think that's closer. Well, it looks like something else is going wrong. Okay, I'm gonna start this from the beginning. Well, it's not from the beginning, but okay, now it's doing what I expected to do. I guess something was off with the camera settings before. But I had to copy that, and now if I do this, okay. Now I think what I need to do is shift this by half. Okay, first of all, this radius is too large. So I go to the OpenGL dot, default dot radius. This is 0.08. It needs to get even smaller. Uh-oh, what'd I do? Gosh darn it. I messed up my thumb. Dang. Okay. There, should be back. Oh man, although I just figured out one of my key bindings isn't working. That's kind of frustrating. But anyway. Yeah, this is offset by a bit. So right times I times the square side length, I'm gonna do plus half of the square side length. And here, same thing. Why didn't it move down the way I thought it would? Oh. It should be like this. This should be like this. Okay, then I can do some factoring here. This is I plus 1/2. This is J plus 1/2. It should be the exact same thing. Perfect. Now, let me bring down the radius of this by 1/4. Okay, this is perfect. Now, what I'm going to want to do now is replace these with squares. So I guess I can just put OpenGL square here. And here I'm using a radius of 0.02. I guess I'll have to do a side length of this, of double this. Let's just see what this does. Okay, let me take out the... Wait. Maybe this is perfect. Do I really need to do anything more than that? Probably not. Probably not. So what I'm gonna do, I'm gonna move the top left and the bottom right just a little bit. Or maybe I'm just off by a... Should I just put a +1? I feel like a +1 would cover both of these. Yeah, I'm just gonna add a +1. It's probably what I'm... It's probably just +1 I dropped somewhere with the rounding. I feel like a +1 would cover both of these. Yeah, I'm just gonna add a +1. It's probably what I'm... It's probably just +1 I dropped somewhere with the rounding. If I do this... Perfect, so that covers the whole triangle. At least enough that I want to do it. Okay, so next thing to do, I'm gonna want these to be a different color depending on whether or not they are inside or outside the triangle also. I think these are all stroke. I bring this down to like 1. Okay, maybe I want that to be like 2. Okay, okay. Maybe I want it to be 1. I want the fill color to be white. The fill opacity to be 1. Okay, now I feel like I made the squares just a little bit bigger. And how would I do that? No, I didn't even make this square side length. Anyways, I'm gonna make these slightly bigger and just see where... Well, that looks fine. 0.06. I'll check out 0.07. That actually looks good too. Great, now I'm gonna want to see if this point is inside the triangle. And maybe I should know how to do this. But I don't. Yeah, maybe it has something to do... It must have something to do with a dot product, right? Because a dot product can tell me what direction something is, what direction a vector is from another vector. But I don't think that's useful without a point in each of these cases. Or is it? No, probably not. No, probably not. I'll just search something up. Inside a polygon. Number of times this ray intersects. Okay. Wikipedia article. Perfect. As whether a given point lies inside or outside the boundary of the polygon, blah, 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 blah. There's a ray casting algorithm. Testimony times a ray starting from the point and going in any fixed direction intersects the edges of the polygon. The point is lying outside the polygon. The ray will intersect its edge an even number of times. The point is inside the polygon will intersect the edge an odd number of times. The status of a point on the edge of a polygon depends on the details of the ray intersection algorithm. Well, I don't want to implement ray intersection either. Maybe I don't need to do ray intersection though. I can do... just line intersection, I think. Well, no, it'll end up being the same thing. The point's winding them with respect to the polygon. It is sum up the angles subtended by each side of the polygon. As for inverse trigonometric functions, which generally makes the algorithm much slower. Look at these inverse trigonometric functions do not need to be computed. Since the result, the sum of all the angles can add up to 2 pi or multiplies of 2 pi only, sufficient to track through which quadrants the polygon winds. Wow. This is all super annoying. Well, am I just gonna implement some ray intersection?